Good morning. Test 1, 2. You all hear me? Perfect. So, who is the first Cisco Live session ever? This one. Who has come? Whose session is the first ever? Okay, a few. Welcome to Cisco Live. Before we start, can I join all of you? Please join this Slido survey. You'll see this very likely throughout the conference. Many of my peers, my speaker peers, use this for some interactiveness in the session. So please join us. I'm going to raise, two questions to you. So for the next hour, I want to welcome you to Cisco Live, here second year in Amsterdam. My name is OliverBoehmer. I've been around, so I think it's my 20th or something Cisco Live, so I've been doing this for a while. I started in 2000, and now I'm working as a principal architect in Cisco Services. So our organization implements, designs network for customers, for partners, for customers. And I've been doing this throughout my entire career here in Cisco. I have a very strong enterprise and SP routing background. So I think my first Cisco Live sessions were around, fast convergence, really deep technical routing topics. But for the last years, I think my focus really shifted to automation. I've done automation my entire life, I think, at least my entire professional life. And as automation also has picked up a lot in the industry, where customers transformed their manual operation to automated operation, my focus has also shifted. I think about 6 or 7 years ago, we within our services organization, which is now like a 30,000 people business across the globe, we also needed to do test automation. And I was one part of the team who developed our test automation framework. And I think this journey that we have embarked on within Cisco, I would like to share some of the lessons that we have learned doing testing for our solutions and also for solutions we are deploying to customers with all of you. Recently, I've also become an active robot framework contributor, so contributing to the open source. So I'm not a developer. I'm a network architect, but I do some development. And so I've also started to work in test automation, contributing to open source software. I think my automation background goes back, and I don't know, some of the seasoned people here might remember this book, Perl. I think it came out the early 90s. So I think this was my first book. I started to write Perl scripts for my own admin stuff. I was doing some sysadmin, so I'm using Perl a lot. Obviously, Perl is no longer really a very famous language for many good reasons. I think a second book that has changed and had made an impact to me was this one. Has anyone heard about this book? There's actually a blog also about this. Anyone familiar with this one? This is how I learned Python. And everyone who wants to learn Python, I highly recommend this. It's really good, very practical. And we actually use it now to automate not the boring stuff, but the boring tests. Typically, for sessions, you start out with the why. Why are we doing test automation? And I want to do it a little bit different. I would like to actually ask you, and now please take up your phone. I would like to ask you in a multiple choice, and you can actually give several answers. Why do you either already do test automation, or why would you want to do test automation? And let's see how this evolves. I'm very happy to see lazy and get bored with the repetitive ask currently being the winner. Let's keep going. I think it stabilizes itself. Needs to be faster. Second place, I don't want to miss something, a very, very critical thing. When you test something that you miss something. I'm extremely happy to see the last 3 ones making the last places. So my boss told me to is obviously a valid reason. So quite often it's an important reason. I've actually last year in Cisco Live, I spoke with a big customer, and they actually mandated from their network design team that when a network design team develops a new service, like a new network service, like on Cisco routers, they hand in the templates for automated provisioning, fair. You need to put templates in there. And they need to submit tests to test this feature. This is like one of these my boss told me so reasons. And I'm extremely happy I can't automate my testing, that this is really finishes last. There are things that you cannot do, but I would still challenge everyone that you can at least achieve a decent amount of automated testing for your day-to-day tasks in the network. So thank you very much for your participation. I want to take you on a small journey here. We want to start with the foundation, and I think foundational is to select the right framework, to select the right tooling. If you go off with the wrong start, with the wrong tool, there's a high risk that you need to re-engineer. And I'm not saying that the choice that we have made in Cisco is the right choice, but I want to throw in some aspects, some considerations that you could maybe apply to your own organization. Then I want to talk a little bit about devices. How to deal with test beds. In network testing, we are not at the luxury of having, I don't know, APIs, and we can just fire up a container with an application. In the network world, it's a little bit more complex. We have routers, physical, virtual, and want to talk a little bit about this. And I think the last part of the session, and hopefully you're going to spend some time, it's like half of this content is really writing good tests, whatever good means. By the way, you can find all of these slides in your app, so you don't have to take pictures. You can find them all. The PDF is available, or should be available now in your application. I saw some gentlemen who actually already peeked. I'm looking at you. So, let's start. Don't reinvent the wheel. And writing a test, like if you start very naively on this, and I certainly did when we started this, a test can be just a script. You can just, I don't know, run an SSH command, do a show output, parse the output using regular expression, and be done with it. And you can do this to a certain extent, but you'll realize that there's much more to it than can be achieved with a simple script. You need to run tests. That's the obvious thing for a testing framework. But you might also have you want to potentially filter certain tests, like you classify your tests into routing tests, HA tests, security tests, and maybe you want to say, I changed something in the routing, I only want to execute the routing test because HA is maybe not important for my current need. So you want to filter. You want to rerun tests, like you have 100 tests, one of them failed because you don't know why, and you just want to rerun this failed test. All of these are capabilities of a good testing framework. Logging and reporting, extremely important. So you want to log and you want to check what happened, especially when there is a failure. You also want to have a proof for your compliance or for whatever, that this is what the output was, this is what I expected, and here I have proof. Very important, you do want to integrate third-party libraries. There's a very big automation community around, and you want to make use of the work other people have been doing, because everybody's demands and requirements are different, so you want to actually look around and import these libraries for extensibility. You want to create macros to not always repeat the same things. And last but not least, you want to parameterize your test cases. So you write one test which might work in many, many different environments, in many, many different situations. So you don't want to hard code stuff in your tests. One note, I'm actually violating this in the examples I give you. I want to keep them short and concise, so I do hard code IP addresses, but I recommend when you start testing, writing tests, you don't follow my example in this specific case. I just want to make it easy for us, for you to read. So now you're looking around. And you actually see a lot of different frameworks, DevOps frameworks, testing frameworks, and what do you pick? And I think I just want to give you a little bit of glimpse of the exercise that we've been doing. And an important consideration for this is you need to target it to your audience. So what is your audience in network testing? Your audience are the people who write the tests. Not the people who execute, but the people who write the tests. And it really depends on what type of people do you have in your organization, your team, that can write tests. And there's some conflict between people who know the network and people who know coding, the developers. Typically, people who code don't know the network, or not too well. But you do want to know the network in order for your test to be efficient and to test exactly what you want to be tested. So the Schnittmenge, what is Schnittmenge in English? The section where it crosses is getting larger and larger because fortunately, network engineers pick up development with our DevNet, for example. But you do want to be mindful of what is your audience, what is your test case writers. And in our case, our network engineers didn't do much coding. So we picked one that is more appealing to non-coders. A second one is you want to pick something with a healthy ecosystem. One of the considerations we had 6-7 years back was to just pick something that some of our teams in other parts of the organization wrote. They wrote like a set of Python libraries, Python scripts to do testing for their case. And we actually, it looked good. It was actually, this looks good, and we have it under control. But we actually decided against it. We said, let's pick one that is active. Let's pick one that many people are using, not only within Cisco, but across the industry. So you do want to pick one that is active. So typically when you select open source software, you go to GitHub, you check, is this repository active? And then you can also make a judgment about, are you potentially betting on a dead horse? Last but not least, while we have introduced APIs over the last decades, there's still a lot of stuff that you need to do in network testing that requires CLI, especially if you go like deep down, you want to have really some low-level commands. So a recommendation is to pick a framework that handles CLI interaction with route as well. And this is more than just establishing an SSH connection. It takes much more to do this really well. Okay, what are my recommendations? And I'm no means authoritative on this, but I'm just sharing like two of my favorites. The first one is here, Robot Framework. Who has heard about Robot Framework before? Wow, I'm happy, so like 10-20% of the room. It is called a low-code framework. What does it mean? In order to write a robot test cases, you don't have to be a developer. It's much more forgiving. It has control structures like if or for loops and stuff for iterations, but it's something that you don't have to be a programmer to write test cases in. It's used by us internally in Cisco. It's actually the one that we picked after we tried to select after our selection process, but also by many, many others. It was actually created by Nokia. So it has an active Finnish development team. But it's also used by Juniper and many of our competitors as well as in the industry. So it's a very versatile framework, and I'm going to show you a little bit about it throughout this session. It has a very broad ecosystem. So it has many third-party libraries that deal with user interfaces, with REST, with databases, with application stuff. So it's a very versatile framework, and you can find it under the link shown here. The second is PyATS. I don't know, who has heard about PyATS? More. PyATS is actually one thing that we developed within Cisco. It was our engineering team that is developing the iOS code, the XR code. So it was used by us, by our product engineering teams, to validate our software. It is extremely popular within the DevNet community, but it is Python-based. So if you want to write a PyATS case, it is an exception. There's an exception to this rule, but you want to be a developer. It's really appealing to developers. The PyATS team is making it a little bit more appealing for non-developers, but it's still not as flexible and not as low-code as Robot Framework. Both of them are Python-based, and you can install them here on the internet, so they're all available in the open source. PyATS is actually available publicly, but it's not open source. But you can still install it as compiled libraries, but you can use it for free, no strings attached. Let me show you a Robot Framework, and I think the reason why we picked Robot was because one of the goals is we wanted to make tests to be reusable. We wanted, if one team wrote a test and another team looked at also creating a test for maybe a similar scenario, they could reuse the work of the others. And I would challenge you that if you look at this and you know a little bit about the routing, you know what this test does. We verify the OSPF neighborship, we parse a specific command, and then we are checking a neighbor ID and the state. And this is what we wanted to achieve, because if someone else looked at this test case and, hey, this is exactly what I'm using, what I need, I'm going to copy this and reuse it for my own. So let's go a little bit deeper what's happening here. So first of all, a test case is, and this file contains only a single test case. You can obviously have multiple test cases in a single file, but a test case passes if all of the keyword pass. As soon as the keyword fails, the test case is marked as failed, and then execution continues with the next test case. What we're also seeing here are so-called, why is this not working? This stopped working. Sorry. It stopped working, but it doesn't matter. So what you find here are keywords, for example, setup test environment, check neighbor ID, where you can hide the complexity from the keywords, or you can also put this into an external file and reuse it. So it's like a macro that you can import and reuse. Then you also have the option to, and this is the extensibility part, to pull in keyword libraries. Robot itself provides a lot of keywords, but these are very, very basic. Like should be equal, or fail, or some others, many others, but they are not very domain specific. So here, what we're doing here is we're pulling in, for example, the PyATS keyword libraries that provide additional keywords, for example, like this show IP OSPF neighbor keyword, the parse keyword. One level deeper, you might ask yourself, so how is this all implemented? How does this all work? We're not having an AI that understands what I'm using. Under the hood, all of the keywords are implemented in Python. So for example, here, if you are typing, if this is importing the library class that is here circled with red, the PyATS robot library class, what actually happens under the hood is that a Python class with the same name is instantiated. So it instantiates a class, and this class provides methods, and these methods are then here exposed as keywords. And so if you want to extend it with your own keywords, it's very easy. You create a class, you put in methods, and you can, there are no limits. Everything that Python can do, you can expose to Robot. So you have typically, and this is what also we have a team that develops these Python libraries for our users, and these are developers. They're paid to do development work with our keyword libraries, and then you have the users, thousands of users, who will then consume them through Robot. So it's really divide and conquer. You have developers who know development, you have the users who know the network, and they can just consume the keywords that they produce. Logging, and Robot Framework is extremely good in logging, and what it does, it provides you with an HTML page that you can view. And for example, this one is one where one of the tests fails and it automatically expands it. So if you look at this and you have 100 test cases and just one of them failed, you don't have to click, it automatically expands. So it's very easy. And by the way, all of these test cases as well as the log are in a GitHub repository that are linked here. So you can look at them yourself, and then you can also review them and actually try them out also in your environment later after the show. PyTS, on the other hand, is a Python-based framework, so I just want to go into much detail here. We have, again, test cases, and I'm really sorry that this thing, now it works. We have test cases here. The verify OSPF neighbor, which essentially does the same thing as the robot framework test that I showed you earlier, but here in Python. It also has something like a setup. So here we are setting, why is this not working? I'm really sorry about this. We have the setup, the common setup on line 4, which initializes the test cases. And then we also have a cleanup. I also had this in robot, but I skipped over it in the interest of time. PyTS, because it's a little bit more complex to write test cases in Python for the average network engineering community. So they also provided something called Blitz, which is like a YAML representation of common test cases. It's still not, I would say, as readable as robot. But you don't have to do everything in Python. So there's some abstraction through YAML available. So after you have done, please pick up your phone. After you have just heard me about the test framework, which one would you pick for your own organization? And there also, you could also pick another one. Wow. I'm surprised. So the number of Python-savvy people here in this room are very high. So thank you very much also for your confidence here. Wonderful. So thanks for the feedback. I'm an active PyTS developer, but not that much. So if you have questions about PyTS, you can ask them, but I might actually pull in other people. I don't have that much experience around PyTS test case creation. Very little experience, so I can answer many more questions on robot. Okay, let's move on. Testbed. Writing test cases is one thing. Actually, the testbed, the device under test, which is the acronym DUT or DUT is called. How do we deal with devices? And I want to share some of our experience. And the first one is that if you want to automate tests for your network, you need to have a good inventory management. I think there are many other reasons for a good inventory management, but this one is a very important one because it allows you to reserve devices. Especially if you want to automate tests and run them very often. You need to have a way for saying, okay, this is my test bed right now. I'm reserving this router, and I don't want another one from my team to actually mess with the router while I'm testing it, because this could obviously ruin my test cases. It also allows you for some remote power off, which comes very handy for high availability tests. Like you build a network and you want to test what happens if a router in the middle reloads. Remote power off, there are commercial units available where you can just power off certain plugs. And it also, coming to sustainability, it also allows you to power off for example, your test bed over the weekends when no one's using it. Captain Obvious, don't hard code stuff. So I think topology is one of the most critical things that you do not want to hard code in your test, because you want your test to be as flexible as possible. Ideally, you want to write a test case to be executed in your lab, but also in production, once you put like the service into production. So everything that's related to device names, I don't know, management IP addresses, potentially links and stuff you want to put into an external representation. And what I'm sharing here is a testbed.yaml that comes from PyTS. And both our framework as well as the PyTS framework relies heavily on this YAML file. And it's really powerful because you can put all of your credentials, IP addresses, everything into this YAML file. And you can also use, you don't want to put any passwords in there, obviously, but you can pull them from the environment, or you can also use decryption for your passwords. If you want to know more about the schema, you can find here a link where you can learn everything about the PyTS testbed YAML schema. $1 million question, physical or virtual devices. And I've had many discussions with customers about it, and also in our team. When I'm testing a network, does it have to be a physical device? And the answer is obviously it depends, which is not really helping. However, I think we see that most people use virtualization. So they use virtual routers, VMs, even some nowadays, also we publish our routers, some of the routers operating systems as containers. So you can run them, which is obviously much cheaper and much more flexible than a really physical device, and also much easier to share. You do want to throw in a couple of real hardware devices, especially when you are into, I don't know, scale testing, or when you are testing very specific platform-specific things in your test. It really depends on your test cases. Generic routing, does your design work? You can do in a virtual environment. If you're really testing, I don't know, quality of service, maybe traffic generators and shit, this is why you need to have physical devices. You see here two frameworks. One is called CML, Cisco Modeling Labs. Who has heard about CML before? Very good. Another one is EVE-NG. It's an open source framework which is quite similar. If you have any questions, further questions to CML, they're downstairs in the World of Solutions in the Cisco education space. And they also allow you to combine the two. So you can link like a virtual lab to a physical router, so you can combine these two worlds and provide a good test bed. Another thing which is extremely important for tests is you want to make sure that the thing that you're testing is in a defined state. If you assume that, I don't know, certain routers have a certain operating systems or certain links are configured in a certain way, especially if you're using physical devices, well, you'll be surprised because you have teammates maybe coming in, changing something quickly over the weekend because they were in an escalation. So preparing your test bed to be in a good state is really important, but it's not easy. But our colleagues from PyTS provided something. It's a module called Kleenex. And this Kleenex allows you to set up a physical network, like to load a certain operating system on it, to put a certain base configuration on it, and extremely powerful, very easy but very powerful, and you can also extend it. So it's very extensible. For those of you who have worked with PyTS, PyTS is known to be very extensible. You can add additional modules. So this is, I highly recommend for you looking into Kleenex. Very powerful tool, small but powerful tool to set up your network and your network environment to be in a defined state. I think we spent some time picking a framework, and here the tie is still out between Robot and PyTS. For those of you who are the PyTS fans, in the rest of the session, I'm focusing on Robot, but I think what I'm saying applies as well to PyTS tests, but the examples I'm using will be in Robot. Who has seen this cartoon, and who knows how it ends? The promise of automation. So you work on the original task, you spend a little bit more time to automate it, then the automation takes over, and then you have more time. we wish. It actually looks quite often like this. You write code, you debug it, you rethink, and you continue optimizing it, and you end up having less time. Yes, this can happen if you don't pay attention. So you always need to revisit what you're doing. Does it really deliver the benefits? And if you realize you're on this path, you better change direction. One recommendation, this might sound totally stupid, start with things that you do very often. We had a project with a service provider customer to automate their network operation or network setup. And I think the team spent half a year automating device onboarding. So when you when you introduce a new PE router in your network, you need to automate this. They wanted to automate it, that they can just say zero touch onboarding of a PE device. It turns out that the number of PE devices the customer rolled out was in the, I don't know, low 10, 20. The number of interface changes or service changes they do were in the number of thousands. Why did they start with the one that they actually do less? So start with the one, not the one that maybe seems logical because you're starting your life cycle with the bring up of a router. Start with the tasks that you're doing most. And also here for testing, start with the tests that you're doing most often. Another very important advice is writing tests is not a software development contest. I'm not ashamed to put my code up on the internet because I'm not a good developer. I'm an okay developer. I get shit done. That's my pragma. I get things done. It doesn't have to be beautiful and doesn't have to win a contest. And quite often in tests, it doesn't make a difference if a test runs 1 minute or 1 minute 10 seconds. So always be aware of this one. And don't be ashamed of saying it's not optimized. Who cares? It gets the job done. And I'm going to throw this thing. Also something that try to use APIs if available. CLIs can change, so try to use APIs if available, even if you're used to using CLIs. However, back to this diagram, if it takes you 5 days to learn the APIs and you just need to write a single test, maybe get it done with CLI. But if you think further, learning APIs is really the way to go. My personal opinion is that a low-code framework like Robot helps with the above. It's just a feeling. My gut tells me if I say someone write a test case in Robot or write a test case in Python, maybe the Robot script is okay to look uglier than the Python one. I think that's my feeling. I don't have solid data to support it. Also very important, you want to plan and organize your test cases in advance. So if your boss tells you, or if you come to your conclusion you want to automate your test plan, first have a look, start to finish, how the test plan looks like, so you can actually start to group things. You can prioritize things. You can, for example, say, I'm doing this specific step here, in many parts of my test plan, so I already know that I can maybe take this task and put it somewhere else. And the outcome of this here is quite often, and this is a directory structure of one of the test cases that we have developed for our own sake. The whole directory structure is also available on GitHub to give you an idea on how you can structure this in directories. And what you see here below in blue are, for example, commonly used keywords. So keywords that are used all over the place, and you put them here in macros so you can reuse them everywhere in here. Tagging is also very powerful. So Robot and PyTS, I think, also allow you to tag test cases. And with tags, it helps you for reporting. but it also helps you for filtering, like the example I gave earlier. I want to only execute my routing tests or only execute my edge availability tests. So tagging things early is very important and can save you time down the line. Try to keep test cases concise, so brief. Don't lump everything into a single test case. Try to be as atomic as you can be. I think the main reason for this is it allows you to separate things out, to say, I only want to run this, or later, if, for example, if you realize that a certain test case is executed multiple times, you can take this test case, put it into a keyword, and then make it available to many other test suites here. So here, we are trying to, like the first one is we set up an edge connection on a router. We configure the routing and we verify that the route is locally there. The next case here, starting on line 21, verifies that the route is visible in another part of the network. The third case sets up another redundant connection to the edge, and the fourth case is it checks redundancy. So it's a lot. I'm saying this is the only way that you can structure this, but this is like what comes to mind when I said be concise. I think one thing you want to make sure is you try to avoid dependencies between cases. You want to avoid that one test case results depend on another test case being executed prior. So I think the best way maybe to visualize this is what you don't want to do.
Du musst das auf deinem iPhone on.
What you don't want to do is something like this, where you actually mistake test steps as test case. So this one goes, it connects to devices, it's the first test case. The second one, it configures something, is the second test case. And here, what this is doing, it defines steps. It doesn't define test cases. Like a test, yes, I can argue connecting to a device is a test case. If this fails, there's no point in doing anything. So it tests something. But for my purpose of testing like the redundancy of a link, this doesn't help me. And here we have a very, very strong interdependency between these tests. Try to treat your test cases as code. So keep them in Git. Don't put them on a SharePoint as text files. Keep them in Git. I guess in Python, PyTS is potentially obvious because everyone puts Python code in a Git repository. But make use of the tools that software development give you, also for robot. So you want to have, for example, some test cases should look nice. They should have the right indentation. Maybe you want to enforce in your organization that every test case should have a documentation. You want to maintain certain style guides. And also for robot, there's a tool called BRKOPS. Who has seen the movie RoboCop? I think. Ironically, RoboCop, I think it's not as deadly, but it certainly tells you if something doesn't adhere to your style guides. For Python, you can obviously use Flake 8 or other linters available for Python. And also, you want to dry run your tests. So whenever someone puts and checks in a new test, you can dry run all the tests just to make sure that there's no typo in the keywords, there's no typo in the variables. So they do some checks that allows you to verify, to catch these errors early in the development lifecycle and not when you actually run these tests on your production network or on your lab network. Who has used Genie parsers? I hope by the end of the conference we can increase this to a little bit more. I think Genie parsers is one of the best things since sliced bread, especially when you work with CLI, so not with APIs, but when you work with CLI, you don't want to use regular expressions. You want to leverage parsers that transform the CLI output into structured data, and this structured data can then be used to parse it and to fetch certain information out of it. And what I'm doing here is I am defining 3 routers. So on line 10, you see 3 routers, R1, R2, R3. 2 of them are iOS, 1 of them is an XR device. So we have different operating systems, and the output is, unfortunately, different between these. You could also add a Junos device, which would also help here. So what we're doing here is, in the test case on line 13, we are iterating through all of the devices. We are invoking a keyword which is defined on line 26, learn OSPF on device, which invokes a Genie parser on 28, learn OSPF on device and the device name. And what this parser actually does, or what this command does, it connects to the device, it fires up, 10 or so different OSPF commands, the right commands for the specific operating system, which is different, like from iOS XE to XR, and puts all of them in the same data structure. So no matter if you're dealing with XE, XR, NXOS devices, you will always have the same data structure that you're dealing with, and then you can do fancy things like and this is like an advanced, I don't want to go into much detail here, but on line 19 and 20, we're using an advanced Genie operation, a very powerful library called DQ, which in this single line gives me all of the interfaces that have an OSPF hello interval less than 5 seconds. For example, my test is nowhere in the network I want to use fast hellos. So I want to rely on BFD. I don't want to use these fast hellos. And this test with a single line gives me all the interfaces on these routers that violate this statement. And by the way, when I showed the log HTML page in the beginning, this is the test that fails because one of the routers in the lab actually has a lower hello interval, and that meets this criteria. Has someone worked with NTC, Network to Code, before? NTCs, and need to do them justice, they also have a very, very good collection, and a community-provided collection of parsers using TextFSM. TextFSM is a pretty cool way, I think invented by Google, to parse text. And the same output using, the same test case using NTC parsers is here. The main difference here is the NTC parsers are not like the Genie parsers where you have, or the Genie Learn, which can deal with multiple operating systems. Here I'm just picking the iOS devices because I would need to use a different parser, NTC parser for the other ones. But you can definitely code this. So here you see on line 19, you actually have the platform that you tell NTC to use, and so it would do the right thing. Okay, we're coming to the end. Negative scenarios is also very important. So what you're seeing here is a test case that creates, and this is in that case that's an XR device I'm dealing with. So on line 16, I'm creating a static route, and on line 19 and on 31, I'm validating if this static route is advertised to another router in my network. So this is the test I'm doing. And it's actually quite often, especially when you're doing static route distribution, that you want to limit the routes that you are redistributing. You don't want to, like someone, redistributing your Active Directory server and black holing all your AD traffic. So you put an access list. So a second test case is actually for you to say, I want to try this with another route that I'm not allowed to redistribute, and want to verify that it's not there. So what you're seeing here, if you compare line 19 with a green arrow and line 26 and 27 with the red one, you essentially have the same test you're executing, but you're negating it. You actually, for the 26, you actually want the test case to fail. And so you can use this run keyword and expect error. And then this makes this one a positive test. So the test case negative route distribution test succeeds if the other keyword fails. And so keep this in mind when you write your keywords. that you can use them also as a negative, in a negative connotation, instead of writing a positive keyword and a negative keyword. It just saves time. I think one of the sweet spots for automation is certainly convergence tests. So the typical tests of I have a complex network, I'm failing a link, and I want to make sure that my traffic is still passing through the network, but I also want to measure how long has the outage occurred. So how many people have had discussions with their voice team about how long an outage can take in the network? Not too many. Yeah, the others can be happy. These are not nice conversations. This one is a test where automation really helps, but it's actually very complex. So I'm not able to give you, to show you a single screen here with a test case. It is actually a test case from our SVS team, who tests the convergence of a line card. It's on GitHub, so if you go to the GitHub repo, you can find the full test case. You cannot likely execute, no, you cannot execute them because it requires some of our internal libraries, and it also requires a traffic generator, but this can be done. I hope that just by looking at the test case, looking at the methodology, it gives you some ideas on how you could run these things automatically. Unfortunately, this is also something where you might need to throw in some physical action, because if you want to, you can reload a router, that's fine, but there are certain failures that actually you need someone to walk into the lab. I actually have a nice story, it was 15, 20 years ago, I visited our XR engineering lab in San Jose, so where the XR routers, the really big routers were built, and they actually had a robot that pulled line cards and was remote controlled. So there was an API, it pulled the line card physically out of the chassis and then pushed them back in. I couldn't find a photo of this, I didn't take one, unfortunately, but I found this a very interesting robot automation with a physical pull-push mechanism. So, wrapping up, so we have a few minutes also for questions. I think what I would like to for you to take away from the session, I think doing the groundwork, selecting an appropriate framework for your test case writers will get you a long way. And we haven't regretted our robot decision. Yes, we've had discussions with Python teams. Robot is so ugly, and it's not a real programming language, and blah-de-blah-de-blah. But our success, we've standardized, I think, between 10 and 15 different frameworks used in pockets of our organization into one. And we're extremely successful internally, and we're also offering this one as a service. So if you want to use our robot framework in your organization, we offer it not as a product, but as a service. So if you're interested to leverage our work for your organization, please approach me or our colleagues. Make sure that you don't hard code your test for a specific topology. Keep in mind that you want your test cases to be valid for years to come. You want your test cases to run on as many different device topologies as possible. So don't hard code. Use virtualization. And one thing that I skipped over is you also want to clean your test bed. So if you visit the slides after the session, there's one area where I'm using teardown. Hello? You still hear me? Hello? I'm glad it's happening at the end. Or do you have a microphone? So you want to leave your test bed in a state where the next test case who uses it can actually pick it up. So you don't want to create something.
It works.
No? Is it? Does it work? No, it works. No. Give it to me.
Yeah, you want it?
This one works. Okay. So you want to be nice to your neighbor. You want to be nice to your other fellow testers. That actually they find the test bed in a state that they are prepared to do. And be pragmatical, focus on repetitive tasks first, and also reuse existing parsers. So I think when you're starting to write regular expressions for parsing output, assume this problem, someone else has solved this problem for you. So stop right there, investigate parsers that we have for commands, and start using them. A lot of links for your education, for your further education, both to Robot and PyTS. And I think that also here at some point are 4 other tests about network automation throughout this week. So there are many areas where we're showing like how we're testing in different scenarios. And we're around for you. So I don't know, for those of you who have never been to Cisco Live, so we have opened a WebEx room. All of you can join this WebEx room through your chat, through your app. And we will keep it open until, I don't know, end of February or sometime. So if you have a question that you're not able to answer, to ask now, over the next week maybe, if you think, I should have asked Oli this one, we are here. We can keep also this room open for longer. If you have any question, please use this WebEx room. Fill out your survey and have fun in Cisco Live. So thank you very much for your time, and